An airplane is flying 875 kilometers per hour at a direction angle of 302 degrees. The plane encounters wind with a velocity of 140 kilometers per hour at a bearing of north 20 degrees east. Draw diagrams with labels to represent the problem. What are the resultant speed and direction angle of the plane? So one piece of information we have is a directional angle of 302 degrees. Remember that a direction angle starts from the positive x-axis and rotates counterclockwise, and it's always positive. So the airplane flying at a direction angle of 302 degrees, we can say theta is 302 degrees, and we can say the magnitude of the airplane, so magnitude of V, is 875 kilometers per hour. We also have wind going at 140 kilometers per hour at a bearing of north 20 degrees east. And so bearing north 20 degrees east, so here is 20 degrees. Therefore, our directional angle is 70 degrees, which is this angle down here. We can say our magnitude of the wind is 140 kilometers per hour. So we have two vectors. So what we want to do is to be able to write our vector equation. So remember that is V equals the magnitude of V cosine theta times I, or cosine theta I, plus magnitude of V sine theta J. So let's write our equations for both the airplane and the wind. So vector V is 875 cosine 302 degrees I plus 875 sine 302 degrees J. Then we have W, vector W, 140 cosine 70 degrees I plus 140 sine of 70 degrees J. So what we want to do is find the resultant vector. So what we're going to do is add V plus W. I'm going to go ahead and write it in component form and plug it into my calculator. So when I do that, then I find my horizontal component, adding the cosines together, I would get approximately 511.56. If I add my vertical components, my sines, then that would be negative 610.49. And so just as a reminder, this tells us our resultant vector is still in quadrant 4, so 511.56, and then negative 610.49. So it's something to keep in mind when we're talking about the direction angle of the plane. So we have to find the magnitude, so the resultant speed, and so that is the square root of 511.56 squared plus negative 610.49 squared. And so when you plug that into the calculator, you would get approximately 796.49 kilometers per hour. So that is our resultant speed. Now to find the direction angle, we're going to use tangent. So tangent of theta equals, and then we're going to look at our resultant vector here. So it's negative 610.49 over 511.56. So theta is tangent inverse of this value. Okay. And then when you plug it into your calculator, you're going to get approximately negative 50.04 degrees. Now, remembering arctangent, the answers are going to be in quadrants 1 and 4. Now, this is fine because our angle, the resultant angle here of the plane, is in quadrant 4. But directional angles are supposed to be positive. It starts from the positive x-axis and rotates counterclockwise. So therefore, to find the angle, and it's in quadrant 4, we're just finding the coterminal angle, and so all we're going to do is add 360 degrees in order to get our directional angle of the plane. So if you add 360 degrees, you would get a directional angle of 309.96 degrees. Now from here, you can also find the resultant bearing and true direction of the airplane. So using the information we have negative 50.04. A couple things here. So let's talk about true direction first. True direction in airplane navigation is that north is our 0 degrees for airplanes, and then it moves in a clockwise direction this way. So therefore, to find the true direction or the airplane navigation of the airplane, we know the angle is in quadrant 4, and we have the angle negative 50.04 degrees. That is this angle here. So the true direction of the airplane is this black arc here. And so what I could do, this is 90 degrees. I can think quadrant 1 is 90 degrees. And think about this instead as negative 50.04. I can think about that as a positive 50.04, 50.04, just as a reference angle. So if I add those two together, 90 degrees plus 50.04 degrees, then we would get a true direction of 140.04 degrees. Now to find the bearing instead, looking at the same angle right here, we have negative 50.04. Remember that bearing always goes towards that y-axis, this direction here. So this is south, so it's going in a southeast direction. Now in order to find the bearing, we're going to take 90, and we're going to go ahead and do 90 minus 50.04 to find what's left over. So if you did that, you would find that the angle here to the south line here is 39.96 degrees. So the bearing would be south 39.96 degrees east.